I'm Sarah Lebner from Cooey Architecture. I specialise in regional, energy-efficient, low-carbon homes that are an absolute joy to live in, and this channel is about sharing some of that knowledge with you. This episode is how to prioritise energy-efficient decisions. Hello from. Today I wanted to show you a live demonstration that simulates the impact of some of the design and material decisions that we make in our homes, and the effect that they have on comfort and power bills. And I hope by the end of this session you have a much greater understanding of the context that certain decisions sit in and what the likely best bang for buck priorities may typically be in a home. So for the last decade we have been getting better at energy efficiency, and we generally understand things like insulation, but I find it's really hard for owners to quantify the exact impact that doing the right thing or investing in quality will have. There's just so much advice on what you can do, but how do you understand that return on investment? Well, as of this year, there's a really new, exciting platform by Powerhaus Engineering that anyone can access, and once you're in their system you can play with all those variables in your house, and that's what I want to demonstrate for you today. We've been using it here at Cooey for around a year, giving our clients and builders that login to share so that they can have a toggle as well, and we think it's just an absolutely brilliant tool, unlocking a lot of that scientific information that was previously sort of behind closed doors and quite hard to access and play with. So this is the interface that we get. And now look, there are a few first steps before I show you a simulation on this particular project. There's a couple of background things to get right that I can't show you and toggle with in here. Now the first one is getting that solar passive design correct. So I will show you our house plan in a minute, but to give you a very quick background on this, if you don't already know, I'm based in the southern hemisphere, in the southern half of Australia, where solar passive design works really well. So if north is this way along a section of a house, in winter our sun tracks lower through the sky, and then in summer it's tracking higher above us, and we can really use that to our benefit. If we have most of our glazing on that northern side with an optimal eave over it, then it means that our homes get all that free heating from the sun in winter, but then are completely shaded in summer. So we can't actually simulate changes today in the design. So I will show you the plan in a minute, and you'll see how we've optimized some of those things already, but I can't stress enough that the first step is getting that design right, and then you can toggle the materials and things that go into it. The other thing that we can't toggle today that I want to talk about briefly is house size. I want to emphasize that the bigger the house, the more it costs to run and stay comfortable. Here we are, Australia, we're building the biggest new houses in the world compared to other homes, and this is a article that I wrote for Lunchbox Architect on 15 reasons why small homes are better. And the other thing to stress there is that home energy star ratings in Australia, NatHERS ratings, they are per square metre. So if you're comparing a 100 square metre home that's 8 stars to a 200 square metre home that's 8 stars, even though they have the same star rating, the one that's twice as big is predicted to use twice as much energy to heat and cool and stay comfortable. So the project that we are going to look at today, just to give you an idea of the floor plan, it is this one in Dalgety. Now Dalgety, if you don't know it, it's right up near the Snowy Mountains. So this is an alpine climate. It is very challenging. And you may or may not know that star ratings are also, it is harder to achieve a good rating in a cool climate. So as you see those numbers as we go through all the simulations, remember that if we moved them to a milder climate, those numbers would jump up significantly. So north is up to the page indicated here. These are the little shading that we've got here indicates that summer and winter sunrise and sunset and where the sun tracks. So, I mean, like all projects, we had site things to deal with, site constraints. So, of course, it's really easy to design a solar passive house. If your view is to the north, you know, you are off to the races. On this house, we had the really wonderful views out to the west, which is quite challenging. So you can see that while we've got a lot of that glazing along the north with the eave over it to our living areas, kitchen and dining, to the primary bedroom and then to sort of this secondary living space, we've also do have a lot of glazing off to the west, and we do have the roof extended over there to assist with some of that late afternoon sun strike in summer, and I imagine there'll be some sort of operable shading or deciduous planting over here. It is 159 square metres, so quite compact and hardworking for a home of this sort of size and inclusion. And to give you an idea of what that looks like in 3 dimensions, here's our 3-dimensional solar studies. So what you can see here is our winter solstice, middle of winter at 9 AM, noon and 3 PM. You can see that the sun is flooding in those windows throughout that whole time. And then we go to our summer solstice at 9 AM, noon and 3 PM. And the sun is not hitting the windows except for this one. This little one doesn't have an eave over it. We'll be planning a vertical blind on that one. So let's jump back into the Powerhaus app here. So what I've started with here are some pretty typical specifications that we might see in an existing home, an older home, not necessarily a new home. So you can see that even just having a nice compact rectangle that's oriented well, even in this harsh climate, our starting point here is 4.9 stars. So this section up here is where you're seeing that star rating. This still puts us in the top 30% of homes in Australia's housing stock. So this is a great graphic that The Guardian put together recently looking at existing housing stock in Australia. You can see that 72% of homes are at 1.8 stars or lower, just to give you a little bit of context there. But rather than focus too much on stars, I want to show you this energy graph that we can see here. So this is the one to keep an eye on as we move through the different simulations. So what we've got in here at the moment, if I go to our systems here, by default, we've already popped in a 6 kilowatt solar system. There we go, we can see it. And we're going to use that as our context setting. So I'm not going to change that 6 kilowatt solar system as we move all these things. So that energy generation line here, that yellow line throughout the year, here's our months through the year, that's not going to change. So that should help you assess how those numbers are jumping around as we do it. We also want to look up, the other feature of the Powerhaus app I really like, is this net zero months. We want to look at our months that we're net zero because that's our ultimate goal, to get this house to net zero operation in the most cost-effective way. Now the reason we look at months is because, you know, we generate stacks of energy in summer in Australia and we don't use much energy for the rest of the house. We use most of our energy in these cooler climates in Australia for heating, and that's also when we're not generating much solar. So that's why this monthly breakdown is really important. This is showing our heating and cooling load over here. We won't get into that too much. So test one, I want to show you just by changing the systems in the house, how we can affect that power use through the year without even touching the star rating yet. So importantly, this star rating that we get for houses, it only talks about the envelope of the house. So both the design, the shape, the orientation and the materials, the insulation, etc. It doesn't then consider how you're going to heat and cool that. A lot of people don't realize that. You could build a 10-star house but then put terrible systems in it for heating and cooling and hot water and still pay a lot of energy during the year. So by default here, at the moment this home is being heated using electric resistance heating. What if we jump that to split system heating? Massive drop down there. So electric resistance heating only has about a 1-to-1 ratio. Split systems, which also can be called a heat pump system, they take typically 1 unit of energy to 4 units of heat, so wildly more efficient for heating. The reason it's a little bit more for, if we go to ducted here, it'll jump down a bit just because there's a loss of efficiency with ducting of those systems. Again, our cooling, we're going to change that to the split system. Here in Dalgety, up in an alpine climate, not a lot of difference there. Our hot water is another big one. If we change that from resistance electric to a heat pump, we should see a big drop in, that was this one down the bottom. I'll just toggle that back so you can see it, our hot water use throughout the year. So already you can see that takes us up to 8 months net zero just by changing those systems, and you saw the big difference there. So I'm just going to toggle these back so we have that same starting point to then look at some building materials. So here we are back to our same starting point. Firstly, we're going to look at some of your sort of basic things that you would do in either upgrading your existing home or if you're building a new home. So let's jump in. First of all, let's improve our insulation a little bit, because really insulation in a standard timber frame home is cheaper these days and pretty much standard practice. So we're going to go to 2.5 for our walls. We've got 2 types of walls here, so we're going to pop both of those in. We're going to look at our ceiling. It's pretty easy to get ceiling insulation these days. We'd usually go up to about R.5 for a new build these days. Now we're also going to look at air tightness. Now there's a whole other talk that could be done on this. So all I will say is that you're more than 15 rating here, that's probably an existing, older, drafty, leaky home. If you're building a new home, you'd hope that you're getting under that. But having an awareness about that, I'll just close these up. Watch this as we change this. So a newer home with just a bit of basic attention to draft proofing, you'd hope would get to this. You can get to less than 5 using standard construction if you just have an educated team on draft proofing. Now the reason, and let's watch if we get down to less than 2, changes happening here. The reason less than 0.6 is here because that is a passive house constructed system. So I was talking about solar passive before. Passive house is a quite different construction system where there's extra internal membranes and sort of less conventional construction. So there is a fair bit more investment in cost at that point. So I love that Powerhaus have brought this in, because sometimes it's helping people see where their sweet spot might be in terms of their investment. So I'm going to leave this here at about 5 because that's where you can get to using standard construction. Now if we go down to windows, that's probably the other thing that I'll change. So I did have, I think I had single glazed aluminium is where we were at the moment. Now if I change that to double glazed aluminium, which is sort of our new status quo for new homes in Australia. All right, Now, we're already at 6.8 there, and maybe I'll just change the air tightness to what we might be sort of more standard on an average new build. We're at 6.3 stars. So up until recently, this was our minimum standard in most states and territories across Australia. So I really want to stress how easy it was to get that house to that standard. If people tell you it's hard, it's not. And then at 6, if we look at the 6 stars there, we're getting up into the top 20% of homes in Australia. Now let's go back. Here we are. Let's go back and review those systems again in our 6-star home. So get our more efficient heating, get our use our cooling as well, and switch our heat pump over here. We are 10 months net zero with just a 6 kilowatt solar system. So we're going to go back through now. Actually, let me just see what happens if we do 8 kilowatts here, for example. That gets us to monthly net zero there with some very standard construction specs, I'd say, these days on a 6-star home. But let's, for argument's sake, go back down to 6 stars and look at how we're getting this home to 8 stars and what that impact has. So back to our toggles here. So the only other things that we really do in our homes is insulate that slab. Now obviously you can't do this if you've got an existing slab on ground, and yes, a lot of homes these days you might be going for that lighter carbon footprint and doing a light and tight system, but for this house we do have a slab on ground, and we'll be putting some insulation underneath and to the sides of that, and that has an impact for sure in this cooler climate. We are going to take that air tightness now down to 5, and now we're going to switch our window frames. So it's still double glazed, but we're going to go with UPVC now, and we're going to, actually I'll show you clear to start with. So drop that down. So aluminium frames are conductive basically. So you've gone to all that effort of paying for your double glazing, but if you've still got an aluminium frame, that frame's still conducting a lot of heat through it. You might have condensation issues. UPVC is fantastic bang for buck in Australia these days, and that's typically what we're using across all projects. So that's gotten us up to 8 stars. We're often using a low E coating as well. One case study I did for a house that only cost $1,200 to add across the house. We worked out it had a payback period of less than 5 years for that house. So now we are at 8.3 stars. At 8.3 stars, back to this diagram, 8.3 stars is in the top 1% of existing homes in Australia. You've seen exactly how we got there with the materials. Let's go back and do that fun swap with the systems. Toggle them all back. And we're very easily at 12 months net zero. Now, 8.3 stars is generally spoken about as the sweet spot between high performance construction or high-ish performance construction and investing in offsetting your remaining power. So that's also one of the points I wanted to make here today. You can go to the nth degree on your construction. It might be really important for you, for example, to go for that extra air tightness and take this down to 0.6 for other reasons. You can see that has made a bit of a difference here, but for the extra cost investment to get there, I'd say the average Australian would more be excited to be achieving that net zero with their 6 kilowatt system. I think that's a really great place to aim for. Now, a couple of extra bonus things. What else can you see in here? I mean, you can go down and toggle some things like going to advanced, and you can play with your areas of shading and your area size. Shading's here, so you can look at different eave depths and things. There's a nice little summary at the front here that talks about the form complexity. So even though our homes are fairly simple rectangle, there's still some points there because we do have some ins and outs and things. We've got a 29% ratio of glass to floor area. Now, normally we're trying to aim for, I usually say 27 or less is a good guide. We've gotten away with a bit more here because it is well oriented and well shaded. But that's a really good rule of thumb, and to think of your glazing as a budget to be used, because even those UPVC double glazed windows can still transfer heat 7 times faster than a standard insulated brick veneer wall. So windows, even if they're great windows, are still a weakness. And it tells us what percentage we are to north. In an ideal world, you'd have this a little bit higher, but we did have that reality of a site view to the west, and you'll probably have your own project reality as well. What about renovations? People usually ask at this stage. In my experience, it's very doable to get a home to 7 stars or close to there through taking those same priority steps that we've looked at today. Usually starting from the top, working down, ceiling insulation, wall insulation. You'll need to talk to a local provider on how you can do your wall insulation depending on your construction. Make sure that your condensation's sorted out. And floors usually the last priority there if you have access to your floor. Appliances are a really big one. Draft proofing is always your biggest bang for buck because it is really easy and cheap to improve. And you've seen today how much effect taking it from that really drafty to a moderately draft proofed, what effect that can have. And also then looking at your appliances. So that's really the trifecta there. I know the Fix-It chicks, they always talk about insulate, get off gas, and draft proof. So it's dig it, DIG, draft proof, insulate, get off gas. And I haven't gone down the gas heating and cooking too much today. You can look at that yourself. So if you liked this, I'm going to be working on a retrofit resource soon where I give people more information on how to do this kind of thing in their existing house themselves and how they can project manage that themselves. And the next question is probably, can you access the Powerhaus system? I'm not affiliated with them. I just think the work they do is fantastic. And the answer is yes. Anyone can get an energy assessment of their home with Powerhaus. You'll just need some basic plans and information about your house. They then plug in the background modelling as their assessor role and then give you access to this platform. So all that background stuff that happens in the back of this using the NatHERS system is very sophisticated. It uses climate files from the Bureau of Meteorology from the last 30 years. It uses your exact location, orientation, materials, builds it all, simulates it. So the data being pulled from here, it is one of the most sort of advanced national systems around the world. We're very lucky to have it. Even more lucky that we have this system that taps into breaking it down for us and giving us more control to optimize so that you can make the best bang for buck decisions. I really enjoyed sharing that with you and I hope you found it useful. If there's anything you think I missed, please pop some questions below and let me know what you want to learn about next. Please like, share and subscribe. Thank you.